Hello, my name is Phil Gibson. I'm a program manager here at Microsoft, and I want to welcome everyone to our first episode of the Azure Upstream channel. Here, we're going to talk about all of our open source projects, and we're excited to kick off this initiative with our goal to really pull back the veil on our projects, show how the sausage is made, and really bring the engineering perspective, process, and activities to the forefront. So this channel is going to be for engineers, by engineers, and we're going to be doing a lot of live demos and really getting into the technical details of all of these projects. So with that, let's go ahead and kick this off. And this first of a two-part series. And we're going to talk about the newly announced Workload Identity project that evolved from an earlier project called Pod Identity and all the journey in between. Links to everything that we're going to talk about will be in the video's description. So with that, let's go ahead and give a round of intros with the core engineering team. Ernest and Anish, why don't you go ahead and introduce yourself?
Hey, I'm Ernest. I'm a software engineer working at Microsoft Azure, focusing on cloud-native open source software.
Hey, I'm Anish. I'm an engineer in the Azure Container Upstream team. I'm one of the maintainers for Pod Identity.
All right, so let's get into this. Let me go ahead and just share out this original project. And then how about Ernest, talk about some of the background of this original Pod Identity project and how it came to be.
Sure. Yeah, thanks, Phil, for the intro. So AD Pod Identity is an Azure-specific solutions that allows users to assign Azure Active Directory managed identity to Kubernetes applications. So imagine you're an application developer on Azure and your applications wants to access some Azure cloud resource. You have a couple of options. First, you can create a service principal, which contains a client ID and client secrets. That's not very secure because the client secret can be leaked and you have to manually rotate it every once in a while to keep your system secured. The second option, which is what AAD Pod Identity is mainly about, is to use Azure Managed Identity. You can think of Azure Managed Identity as a service principal, but without the client secrets. You can attach Managed Identity to different kinds of Azure resources like VM, VMSS, or even AKS clusters. This is beneficial because one, you don't have to worry about client secret being leaked. And also you don't have to manually rotate it every once in a while. With that being said, let's apply these concepts to the Kubernetes layers. Let's say you're a Kubernetes developer on Azure and your Kubernetes applications wants to access some Azure cloud resources. For example, one of the most popular way to access cloud resource is fetching a secret from an Azure Key Vault or downloading files from Azure Storage. You can either create a service principal, which is not very secure, as I mentioned earlier, or you can create a managed identity, which is what we recommend. But as I mentioned earlier, you can only attach managed identity to the VM level or the AKS cluster level. And once you assign a managed identity to your clusters, all the applications within the cluster will have the same access to the same set of Azure resource, which is not very ideal in some situations. You might want to restrict a particular applications to only be able to fetch a secret from a key vault, but you don't want that applications to access some unauthorized cloud resource on Azure. So this is where AAD Pod Identity comes in. Not only does it help our developers to assign managed identity to individual Kubernetes nodes using the concept of Kubernetes custom resource definitions, but it also acts as a gatekeeper to make sure all of the Kubernetes applications are using the correct managed identity that they're supposed to use. And there are two main components in AAD Pod Identity: the Managed Identity Controller, or MIC, and the Node Managed Identity, or NMI. MIC is the controller for assigning and unassigning managed identities from the underlying Kubernetes nodes, which are basically Azure VMs. NMI is a daemon set that intercept traffics to the instant metadata service endpoints, which is a specific endpoint that exists in every Azure VM. You can request an access token from IMDS for a specific managed identity, and the access token is what you can use to access Azure resources. And developers who are using AAD Pod Identity will begin by creating 2 Kubernetes CRDs, Azure Identities and Azure Identity Bindings. Azure Identity is basically a representation of an Azure managed identity. It contains the client ID as well as the resource ID of the managed identity you want to assign to the node. Next, the developer will create Azure Identity Binding, which is also a CRD that binds an Azure Identity CRDs with a pod using labels in the pod's metadata. Finally, the developers will create their pods with the particular labels defined in the Azure Identity Binding. And once the pod is created, MIC will assign the managed identity defined in Azure Identity CRDs to the underlying nodes, and which is where the pod is scheduled to. So once the identity assignment is complete, the pod can start accessing Azure resources with Azure SDK. And under the hood, Azure SDK will fetch an access token from IMDS, which is, and the traffic will get intercepted by NMI. NMI validates that the request is valid. That is, the pod is requesting access token is actually using a managed identity they're assigned to. With this validation, we can block any pods they're trying to use a different identity that they're not supposed to. And after the validation is complete, IMDS will return the token to NMI, and NMI will return the token to applications. And with that being said, I'll give the mic to Anish to show us a live demo.
Sure.
Good stuff. Yeah, I mean, as we mentioned, this is going to be super technical. So I'm hearing CRDs, IMDS, NMI. So Anish, yeah, help us kind of make sense of this and visualize kind of all these different connections in the project.
Yeah, sure. Thanks, Ernest, for the motivation and also talking about the project in detail. So now that we've given a background on what pod identity is and what the motivation is behind it, let's take a look at it in action. So what I have here is a 3-node AKS Kubernetes cluster, which is running Kubernetes 121. So when we talked about the motivation and also the project, I think we had 2 scenarios, right? Like what is life before pod identity and what is life after pod identity. So what we're going to do even with the demo is first, let's look at the scenario where there is no pod identity in the cluster. And we have 2 managed identities assigned to the underlying VMSs. So to get tokens using a managed identity, the identities need to be assigned to the underlying VM or VMSs, like Ernest mentioned. And for the purpose of this demo, what I've already done is assign the identities to the VMSs before. So first, let's run the command to just make sure that the identities exist. So if you can see in this output here, we can see there are 3 different identities, right? And then the first identity here is what AKS automatically assigns for each VMSs. This is the cluster identity. Then the second and the third identity here is the ones that I have created and manually assigned to my underlying VMSs. To show how we get a token before pod identity, let's first create a namespace in this cluster for the demo. Now that we have a namespace, the first thing that I'm going to do is I'm going to actually try and run a pod in this particular namespace. So as you can see in this kubectl run command that I posted, we are actually just running an Azure CLI container in a pod. And then from the pod, what we're going to try and do is try and get an access token for a particular managed identity. So AZ login -i. So -i is where we are telling login using a particular identity. And then the -u flag here is to specify which particular identity that we want to use for login. So in this particular command, I'm using the identity, and then I'm using ID1 to log in. And then when I run this command, we can see that the login succeeded. And then if I try to get an access token with this, we can say that I was able to get an access token without any issues. At the start of the demo, we had two identities. So just to validate, let's also see if we can get an access token with the second identity that was there in the cluster. So now I'm going to try and do AZ login, but this time I'm using ID2. And as you can see, the login succeeded. And if we try to get an access token, that works too. So we are getting a token for ID1 and ID2. And without pod identity, any pod running in the cluster can get a token from any of the managed identities, and it can use it to access Azure AD protected resources. So in the scenario where you have ID1 targeting Key Vault, which should be used by pod 1, and then in a scenario where you have ID2, which is configured to only access storage, and you only want pod 2 to access it. Without pod identity in the picture, there is no way you can actually control this. Pod 1 can get access token for both the identities, which means it can access Key Vault and storage. And then pod 2 can get access to both identities, which means it will access both these resources. So comes pod identity. So what we're going to do now is deploy pod identity in this cluster and then see how it prevents this scenario and then enhances the security model in the cluster. So we're going to be deploying pod identity using Helm here. And then I'm setting up a couple of flags that we need here. And then I'm also deploying it in kube system namespace because NMI runs with host network and it's a privileged pod. And the recommendation is to run privileged pods in kube system namespace. And then when we run this command, as Ernest mentioned before, we would have our two different deployments and a daemon set that's being created in the kube system namespace. So let's quickly confirm if the two components that make up pod identity are up and running. So as you can see, the MIC controller is running. And then let's also check if the NMI pods, which are run as a daemon set, they're also running. Okay, so we can confirm that both of that is running, right? And the configuration for which identity the pod has access to is done by creating an Azure identity and Azure identity binding custom resource within the same namespace as the pod. So before we do that, now that we've installed pod identity, let's check if the pod that we created in the previous step, can it still get access tokens using managed identities? So I'm quickly going to get into the pod and then run the same command that we ran before. But now that we have pod identity installed, we should see that when it's trying to get an access token from IMDS, the request should just keep failing. And as you can see here, the Azure CLI is constantly retrying to get a token because of the internal retries that it has. But every token request is constantly failing because the NMI component in pod identity is denying these requests because we have not configured the Azure identity on the binding. So next, what we're going to try and do is create an Azure identity and binding in the same namespace for the pod to tell that this particular pod can access ID1. So if you see here, it's a pretty small YAML. So the first thing that we're going to create is the Azure identity. And then you can see it has a name. And then the resource ID and the client ID here are reference to the managed identity that we've already created before. And then the next thing is called Azure identity binding. So basically, we are binding the Azure identity from the first step to a particular selector. And the selector here we have is ID1. So I'm going to create this in PI demo namespace. So now that it's created, let's just quickly check the status of this. So if we see Azure identity, it's for this particular client ID. And then let's also quickly check the Azure identity binding in the namespace. So if you see, it's for this particular Azure identity, and then the selector is ID1. So that looks good, right? When we created the pod first, we used the label with AD pod ID binding equal to ID1. So if you notice, the label value matches the selector we just defined in the Azure Identity binding, which is ID1. So with this, the Azure Identity binding should bind the pod to the Azure Identity. And hopefully, if things work correctly, the pod should be able to get a token when we try again. So now let's try to get back into the pod. And then let's run the same AZ login command that we ran before, which failed with pod identity. So now that we've configured pod identity, this should hopefully succeed. So as you can see, the AZ login worked fine now. And then if we do AZ account get access tokens, we can see that we were able to get an access token. So we have verified that now with the Azure Identity and binding, we were able to get a token for ID1. But also, just for the sanity, let's confirm that when we try to get a token for ID2 from this particular pod, the request should fail. So now in this one, I'm doing AZ login again, but now I'm requesting for a token using ID2. And then if I run this command, we should see that it's retrying to get the access token from IMDS, but the requests are just constantly failing. So if you look here, it's a 404, and then this is an error written from NMI saying, hey, look, you haven't configured an Azure Identity and binding, so I'm not going to give you a token. So with pod identity, we can make access to managed identities more granular by having them tied to individual pods within the namespace. So that's it for the demo.
I like how you ensured like there was no smoke and mirrors there. I think we went into details there. So that's great. Like, so now we can provide Azure identities to pods to access Azure resources. But, you know, as great as this project is, there's still some limitations, right? So, Ernest, you want to talk about some of the limitations about this?
Yeah, thanks, Anish and Phil. That was a great demo. And as Phil mentioned, there are tons of limitations. AD Pod Identity is a really old project, and I can summarize in a couple of points. First, the identity assignment generally takes around 40 seconds to complete. In the demo, Anish pre-assigned the identities to the VMSS, which is what we recommend if you don't want that 40 seconds delay. But if you didn't assign the identity beforehand, it usually takes around 40 to 60 seconds for the identity to get assigned. This means that applications will have to wait 40 seconds before the, wait 40 seconds in order to get access to Azure resources. Second, this solution only works on Azure and only works on Linux machines. And we have gotten a lot of requests for pod identity on Windows. We do have a prototype for pod identity on Windows, but we decided to drop it because of its complexities. And last but not least, over the past year, we've encountered some IMDS caching issues, which causes a lot of users not able to fetch tokens, even when they configure everything correctly. So these are the limitations that we have that are preventing us from scaling further.
Awesome. Yeah, those are pretty good detailed issues that we know about, and the motivation to this newer project we're going to talk about. So great. So now we understand the motivation of the original Pod Identity project, and understand, we're going to understand some of the newer enhancements we're going to see with the new Workload Identity project. So with that, we're going to go ahead and end this episode. Stay tuned for the next episode where we dig into workload identity and all of the workings of it and all of the enhancements. So thank you, and tune in for episode 2.